Okay, kids, when you have to learn how to divide the complex numbers, you will have to go back to the concept, to the topic, to the things where you learned how to divide the irrational numbers. Do you remember when you had under root 2 over under root 3? How did you complete this division? Does anyone remember? Yes?
सर अंडर रूट 3 ओवर अंडर रूट 3 से मल्टीप्लाई करेंगे.
That is called the rationalization of the denominator. So this division is completed. The moment your denominator is a rational number, its third form is over. That means the division has been completed. Okay? And there were the cases like when you had 2 over under root 3 plus 1 maybe, and then you had to rationalize this denominator, okay? So then you have to multiply this with under root 3 minus 1 over under root 3 minus 1. Remember this? So this is 2 under root 3 minus 2 over 3 minus 1. So that is going to be under root 3 minus 1. Now this division of complex numbers is the same. Now as you call this thing over here, the rationalization of the denominator. So this can also be called the realization of the denominator. So dividing um, anything with a complex number uh, can be done by realize, like, you know, you just make this all this complex number a real number only. Okay, so now you see that, for example, you have 17 minus iota over 3 plus iota. Okay, so you will be multiplying this with 3 minus iota, and you will be dividing it with this as well. Okay, now you will multiply it like this 17 into 3 will give you 51. 17 into minus iota is minus 17 iota, and then you have that this minus iota into 3 is going to be minus 3 iota. Minus iota into minus iota is going to be plus iota square all over. Now, if you remember yesterday in the last class, we were told that a plus iota b times a minus iota b, that is a square plus b square. If you remember this, you will save your time that you might spend on expanding the way we have expanded the numerator here. So you can simply say this is going to be 9 plus 1. Okay, so this 51. Now this iota square, what is this iota square? Isn't it minus 1? Yes. So 51 minus 1 is going to give us 50. And minus 17 iota minus 3 iota is going to give us minus 20 iota. Over 10 and over 10. You have to always split them. This is 5 minus 2 iota. You see that it says write in this form x plus iota y. So this real part should be separate from the imaginary part. You can't just write it like this, 50 minus 20 iota over 10. This is not allowed. You have to split them. Your final answer should be something like this. Okay. Now let me write one question from myself. Suppose you have 3 plus 2 iota, and that is divided by, let's say, uh, this is 5 minus 2 iota. Okay. So how can I realize the denominator or complete this division? I'll have to multiply this with 5 plus 2 iota over 5 plus 2 iota. Okay. Now the numerator, we have to expand this fully. Now this 3 into this 5 will give me 15, and then 3 into this 2 iota, that will give me um, plus 6 iota, and then this 2 iota into this 5 is going to give me 10 iota, and this iota, 2 iota into 2 iota will give me plus 4 iota square. Okay, and then I have here 25 plus 4. You always do it like this, using this fact here, like, you know, this a plus iota b into a minus iota b is a square plus b square. So we have now this 4 iota square is equal to what, bacho? 4 iota square is, yes,
-4.
minus 4. Jeete raho beta. 15 minus 4 will give me 11, and this is going to give me 16 iota. This is over 29, and this is over 29. Now you try the parts F, G, and H of this question.